Welcome to CE Chat, hosted by Cloud OnAir, live webinars from Google Cloud. Just a reminder, we are hosting these webinars every Tuesday. My name is Jay Smith. I'm a Cloud Customer Engineer here at Google. And today I will be talking to David Aronchik. Nice to meet you.
Thank you very much.
Today we're going to be talking a little bit about KubeFlow. And just as a reminder, guys, we encourage you to ask questions anytime on the platform, and we have Googlers on standby to answer them. And we'll get to some of them at the end as well. So let's get started.
Great. Thanks so much, Jay. As you mentioned, we're here to talk about KubeFlow. That's machine learning on Kubernetes, or as we like to say, cloud native ML. And I think it's a really interesting time to be talking about machine learning and Kubernetes together. The reality is that everyone hears about how great ML is. They want to adopt it and immediately make changes to their business. And I think the problems that a lot of people have today is it can be very complicated, and there's a big distance between the actual vision of ML and getting it going off the ground. A lot of people today, say ML is great. They hear about it, it's in the news, they hear it from their colleagues and friends, they want to go and solve a bunch of problems very quickly.
Definitely a big buzzword, and everybody's trying to invest in it.
Absolutely. And the reason is because of things like this. This is something that Google did specifically. This is Google engineers, Google data scientists who spend their entire life getting great at data centers, using renewable energy, using the latest technologies. And then they go and they attach an ML solution to the problem to handle the power and cooling and management of their data centers. And almost instantly, they were able to save 40%, a huge amount of money, by attaching machine learning models to these frameworks. So they were able to make a huge difference, already better than the best in almost any industry just by using this machine learning technology. And this is something that a lot of industries are really excited about. And they're like, well, geez, I'd love to get some of that as well. Unfortunately, machine learning is very hard. And it's not just because I'm terrible at math. It is because this is the reality of machine learning. On one side, you have that magical AI goodness, which is so easy to see, where the benefits are so powerful. And on the other side, you see where most folks are today. They have old style legacy infrastructure they need to integrate with. They have very large data sets that they're trying to manage and maintain and make the most use of. And there's so much distance between where they are today and the magical AI goodness in the future.
Well, that's pretty extensive there. Just not a magic wand like a lot of us think. Just throw pictures and get a result.
Yeah, no question. There really is no magic wand. The reason is there's no magic wand is because you basically have this reality. There are two sides of the world. Side one is where you have these do-it-yourself solutions, where you set it up from scratch, where you integrate with legacy systems. And then once you've finally done all that work, which can be weeks, months, years in order to do that, you often have to do it all over again as you need to migrate, as you change your solution, as anything in your system overall changes. The other side of the coin is around hosted. And I should say this is not all hosted solutions, but certainly this is the trend. In the first 5 minutes, it looks great. You're immediately able to make progress, change the way you do your business, and at least experiment with a model. But then in the next 5 years, you face everything you did in the do-it-yourself scenario. You have the same customization issues. You have the same legacy systems that you need to integrate. Plus, now you're locked in. You've used a framework or a model that only works on a single cloud, and you're kind of out of luck. So the question is, haven't we heard this story before? And the reality is we have. Before I came to work on KubeFlow, I was working on the Kubernetes platform. And Kubernetes, when it first came out in 2015, it was a very, very similar story. The reality was that containers in Kubernetes in 2015 and before was a highly bespoke solution. You had to come up with a lot of custom tooling, frameworks, and so on in order to get things up and running. And in order to wire everything together, it became an enormous amount of work. You had to have entire teams dedicated to that. When Kubernetes came along in 2015, you now started to have a standard set of APIs and native ways to handle the complexities of distributed computing. And that really changed the game. People started to leverage the Kubernetes native platform to go to the next level up. In KubeCon Austin 2017, in last December, we talked about some of the ways that we really have started to unlock that future.
Right. You guys were just at KubeCon EU as well, right?
That's absolutely right. And the way that we were able to unlock that future was with these native extension points. Mm-hmm. You have all these various components that operate in layers, from all those runtimes and plugins, moving up the stack to the new API layer, application layer, governance layer, so on and so forth. But each of these had very clean lines, and they enabled people to swap out the things that made the most sense for running Kubernetes. And what that ultimately resulted in is people being able to run cloud-native applications. Applications for running containers that used all the things that were provided to them without any customization. And so, what we would like to propose around machine learning is cloud-native ML, a similar approach to the system, which adopts the core components of what makes containers and Kubernetes so strong, that is composability, portability, and scalability. So for each of those, I think it's worth just a moment to talk about how they apply to machine learning. When you think about composability, first you think about building a model around your machine learning solution. And that's certainly something very interesting, whether or not it's TensorFlow, Caffe, CNTK, MXNet, PyTorch, you name it. There are many, many different ways to build a model, and people get very excited about that. But the reality is, when it comes to building a machine learning solution, it ends up being much, much more than that. You end up having all these various components that you need to integrate, and each of those components are often slightly different based on the data scientists working on it.
Yep, that's definitely not magic there. That is a lot of work and a lot of knowledge and a lot of skills needed, right, to make any of this work, right?
Yeah, so, and I think that's exactly right. Data scientists have skills in particular areas. They want to use the frameworks that are familiar to them, the tools that are familiar to them in each of these various stages, from data to experimentation to production and ultimately rolling it out. And I think that really speaks to how you have to have these things be composable. So if you have a data scientist in one organization, they can use standard techniques and then swap them for a different set of techniques for a different data scientist in a different org.
All right.
So that's kind of category one. We want them to be composable and let people choose what makes sense to them. Category two is around portability. So earlier we talked about all the steps involved in a machine learning framework, but even that is just the start. Then you start to talk about all the elements in your stack: OS, drivers, runtimes, so on and so forth. It gets very, very complicated. And to set up even one of these environments can be very challenging. Yet, the average data scientist often faces multiple of these. They might start on their laptop or on a private rig. They might move to a training solution, training cluster, and then finally into the cloud for final production and training at scale. And to have a portable solution that works in all of these places would greatly speed their ability to work, instead of having to have them set up a custom, bespoke solution for each one. And then finally, we get to scalability. Scalability is often thought of as just the number of machines, but really in machine learning, it's much more than that. It's accelerators, things like GPUs, TPUs, CPUs, the speed of your disk and networking, whether or not it's a fixed disk, SSD, so on. And then it's not just physical assets, but it's actually human beings. How do you scale people with different skill sets? Interns, SWEs, data scientists, researchers, IT ops. How do you scale various teams if they're geolocated, even if they're sitting right next to each other, but they happen to have different focuses? And ultimately, how do you get more experiments? How do you run them simultaneously, and so on? So those are the three things that we think make up cloud-native ML: composability, portability, and scalability. And what we think is a great solution for that is containers and Kubernetes. That's really what they were designed for. Loosely coupling a number of microservices together and making it very production ready and scalable. However, if you want to use machine learning on Kubernetes, it can be very challenging. There are a lot of core components that are involved. Containers, packaging, service endpoints, persistent volumes. These are often very new concepts to people who are familiar really with just VMs and disks. And even worse, if you get into the data scientist realm, where they really just want to focus on their experiment.
Right. Yeah, I remember when I first started getting into containers, it was very different than what I used to do. And I actually started using containers just as kind of like makeshift VMs, not using them to their full extent. And first you have to learn that aspect, then you have to now learn the machine learning, or as you said, data scientists just care about the data. So.
Yeah, absolutely. So that's why we introduced KubeFlow, a way to set up a complicated but composable, portable machine learning framework in a way that takes advantage of all the advantages of cloud-native machine learning. We want to make it easy for everyone to develop, deploy, and manage portable, distributed ML on Kubernetes. And it's really important that we mentioned that last term about focusing on Kubernetes. Anywhere there is a Kubernetes deployment, this runs great. So whether or not that's Google or on-prem or on VMware or on other clouds, as long as there is a Kubernetes conformant cluster, you can set up and run KubeFlow. And I will show you how that works in just a second. The way to think about it is thinking back to all those various stacks we had earlier. You have Kubernetes as this base layer. You can be assured that it runs everywhere. That's a core vision of the Kubernetes project. Then you describe your overall complex deployment using KubeFlow native tooling, and you're able to stamp out KubeFlow in all of these various locations. And specifically, as Jay mentioned, at KubeCon EU on Friday, we announced KubeFlow 0.1, a significant new milestone for us to get out the door and start helping people really start to use use KubeFlow in their enterprises to solve problems today. Today in the box, we have a Jupyter Notebook, we have distributed training in the box, we use multi-framework model serving, and I should really stress right now that though flow is in the name, we really think about that as machine learning flow and not TensorFlow. We support Caffe, PyTorch, and we have lots more frameworks coming soon. Our goal is to really support whatever a data scientist needs using standard packaging for customizing it yourself. And so with that, I'd like to show you just a very brief demo about KubeFlow. Let me just swap over here. You'll forgive me, this was a live demo this morning, but just because we have to run on this laptop, we're going to use a recorded video of the one I did earlier. So what you have here is a standard Yelp analysis, Yelp sentiment database. This is public data. And in the public data, basically, there's all the various results from Yelp content. They have large comment databases, and you're able to see through and page through all the various information. In this case, you have a variety of different things. And looking at this middle one, it's a lot of words, but really, I think as humans, we're able to see that it works properly. A little on the pricey end for baked goods, but the baked goods work good. Also, their coffee products are great. These are a lot of words, but clearly as humans, we're able to see it. However, when you apply this to a standard machine learning framework, a standard solution today, it may not look as obviously correct for these folks. It's often very, very hard using regular expression and analysis to have a system go and look at this. So let's actually try, and we hit the prediction sentiment, and it didn't come back very well. So that's not exactly what we want to see. I think it's actually kind of funny, when you think about it, what you might come up with for a solution here is, well, maybe I'll just do some regular expression matching against the underlying code. And looking at this regular expression matching, you're looking at it and you're like, well, all right, oh, geez, someone commented out good and great. We're just going to try and find things where it says annoying, terrible, and bad. Not ideal. It kind of works, but obviously it missed on some of the things that we were looking for earlier. Mm-hmm. So what I'd like to do is I'd like to use machine learning to try and solve this problem. The Google team, the Google Brain team, as we call them, actually I think that is literally their name, released an open source machine learning framework called Tensor that is very, very well designed, or excuse me, kind of pre-built for handling a lot of these language issues. And you can see here, this is an entire set of things, describes how to install and run these various things, which is obviously pretty complicated, but you can see some of the things that it's really good at. It's really good at things like image language, or image classification, language modeling, sentiment analysis, and so on. And so really that sentiments analysis is what we're going to try and set up here. That's just a demo script. Everything here is really happening. That's just demo script to kick everything off. And what we're going to do first is we're going to set up a standard machine learning framework on your local cluster using something called MiniCube. MiniCube is an application that runs on your laptop, and it creates a real-life Kubernetes cluster running locally so that you have as little difference between your laptop and ultimately what you run in production. So what we're going to do here is, first, we're going to start using MiniCube. MiniCube is already running in the background. I'm going to switch my cube control to point at that MiniCube. And then I'm going to run a deployment of KubeFlow core. That is a standard package that we have in KubeFlow. You just execute literally that command. That KS there stands for KSNet. And you apply it to MiniCube. And what happens immediately is it goes and deploys all of the various components that you might want for a core machine learning framework. It gives you TensorFlow, it gives you Jupyter Hub, it gives you an ambassador for HTTP proxy, it gives you a distributed job framework, and it gives you a dashboard. So really, really powerful right out of the box. It gets going. And like I said, it starts up with a Jupyter notebook. In this case, accepts any username and password, so you don't want to enable this to the web until you get it going. But you can see here, you're able to go and select an entire array of various tools. We come with a number of different packages built in for running your kernels, whether or not it's CPU or GPU, a whole variety of TensorFlow frameworks with various notebooks. And then it also allows you to do things like set the CPU, set the memory, extra resources, including things like GPUs, which is obviously very, very important. So with that, we're not going to do interactive Jupyter training today. We've already decided to use TensorFlow, and it's pretty good. So we're going to do what's called distributed training. That's where you take that model, that tensor-to-tensor model, you package it in a container, and then you're able, with a very few amount of commands, and you're able to distribute it across an entire cluster. And that means that it's up to you to now decide how many nodes you want to use as part of your training. So if you wanted to go faster, you could add 10, 100, 1,000. If you wanted to go slowly or you're more cost conscious, you could use just 2 or 3. So we'll go and we'll do that. To run a distributed training, you need to do one command, or you need to do 2 things. The first thing you need to do is set some parameters. And this is really where the power of KubeFlow comes from, or starts to highlight. First, you saw me set up an entire framework earlier using a very straightforward command to select the package that I want. But now I'm able to set parameters for the specific job that I'm going to run without changing any of that underlying code. And these are parameters you understand, whether or not there's a GPU present, how many workers there are, where I'm storing my data, all these various things. You're able to do it just like setting any other variable. So I'm setting up that for distributed training, and here I am. I'm kicking off with this same command you saw earlier. I'm kicking off tensor-to-tensor, which I have built into a container. And just to prove that it is in fact running, here you can see that the tensor-to-tensor job is running. It's running against CPUs because I'm only using my local laptop, and I want to have it run. And here you can see you get the exact same logs that you would run from any normal TensorFlow job with all the appropriate information there. Again, nothing special here. This is just, I wouldn't ask you to read this wall of text. I'm just pointing out that this really is a real live job running, and you saw me execute just 4 or 5 commands to get it up off the ground. All right, so now that I've done that, it's running okay. But what you saw is you didn't see any syntax errors. You know that it ran properly. Maybe it converged, maybe it didn't. that's OK. All I'm really doing on my local laptop is making sure that this does run properly without any errors. What I'd like to do now is, now that I said, hey, this does run great, I'd like to take it to a cluster in the cloud to run that training very, very quickly. And so in this case, I've set up a GKE, a Google Kubernetes Engine cluster. It runs on Google Cloud, obviously. And it's going to run with two different sets of nodes. First, it's going to run with GPU nodes. And those are the absolute latest from NVIDIA. With a whole variety of different nodes and node pools. You can see here that we're using 8 NVIDIA Tesla P100 accelerators attached to those nodes. And then second, we're also going to use the brand new TPUs from Google. Oh, let me just do that. You can see the P100s there. And second, we're going to use the TPUs. Those are the tensor processing units attached to the same cluster. And we're going to run those jobs simultaneously across those clusters to see which one runs first. Sometimes P100s run better. Sometimes TPUs run better. It doesn't matter to us because it's so easy to set up multiple of these, we can run the experiment ourselves. And you can see here, this is what the TPUs look like, and they support TensorFlow version 1.7, so we'll make sure to support that in our notes. OK, so now that we've kicked it off, we're going to run this, and now we're going to switch to that cluster that I just showed you, and we're going to apply that exact same deployment that I ran locally. And again, this is part of the power of KubeFlow. I don't have to make big changes. In fact, in this case, I'm making no changes. From the exact same deployment I had locally, I'm able to deploy to my GKE cluster. That makes it easy for me to get started, easy for me to have reproducible machine learning and data science. And you can see there, it's updating it in the cluster on the cloud. Next, I'm going to kick off my GPU training. Again, I'm going to use that same package that I had built earlier for running on my local machine that was running against CPUs. But this time, I'm going to change the parameters and say, no, in fact, I do have GPUs on these nodes, and I want you to pick it up. And then I'm also going to change here where the data is stored. And again, I'm doing that based on parameters, not changing code. And I apply those, and those should be kicked off momentarily. Second, I'm also going to deploy that to TPUs. And so again, I'm going to change a parameter to make sure that this new job is running against TPUs. And I'm also going to use a slightly different build. Unfortunately, today, you have to build different versions based on whether or not you're using GPUs and TPUs. Again, for data scientists, this is great because it means you're able to package and describe exactly how you want that model to run. OK, so we're kicking that off as well. This time, I don't have to go into my local logs to do it because Google Kubernetes Engine actually has a great UI for me to explore what jobs are running simultaneously. So here you can see all the logs, the current loss rate. It's happening very quickly. It's saving checkpoints into that Google storage bucket. And you can see here all the various jobs that are running simultaneously. OK, so the jobs are kicked off. They're running. Again, we're not going to bore you with how long it takes to run all these. I'm going to use, in fact, TensorBoard. And in this case, TensorBoard also ships with KubeFlow. It's built in. And it shows you how quickly things are stepping through the overall process and how quickly things are resolving. Great UI. It helps your data scientists really debug and understand what's going on under the hood. And most importantly, it ships in the box. You saw literally exactly what you saw earlier is what's running now. I didn't have to do any special new packaging or distributions to run this. And yet, it ran great on my laptop. It ran great on GPUs and TPUs. And in this case, we're able to see, roughly speaking, about 16.5 steps per second for the TPUs. And you saw earlier about 3 steps per second for the GPUs. So in one command, I'm able to test against multiple different accelerators. And in this case, the TPUs came out about 5 times faster. Really, really powerful stuff. And we're really, really excited to show you. And then finally, like I said, the demo needs to be short. So we'll try and jump forward here a little bit. Also included in the KubeFlow box, I promise, it's not unlimited, but there is a lot of stuff in there, is TensorFlow serving. So in this case, you have TensorFlow serving, which means we're going to take that trained model and we're actually going to be able to serve it and attach it to that Yelp review you saw earlier. We deploy that serving, and now we're going to, we're going to swap over. You can see here in the Google Kubernetes Engine UI that the tensor serving is running and it's ready to receive results. So we'll go back to our Yelp review. This is a different web page that is now designed to use ML. Here were the original results. All wrong, one that was happy when it should have been sad, one that was sad when it should have been happy, and then the final one that was happy when it should have been sad. And we're going to reattach that, swap back over, and go over to the UI and hit the predict sentiment again, and it now comes out correct. And so that's really the summary of KubeFlow. It's a very, very straightforward framework that really empowers you to make decisions about the best machine learning framework for you without having to worry about any of this stuff under the hood.
Yeah, I mean, that's definitely, seems like it's leaps and bounds for machine learning, because I can, like you showed with MiniCube, run the cluster on my machine, and whether it be servers in a colo or servers in my office or even a cloud, Google Cloud, I can just move it and continue running my models with more power. And then, of course, it comes packaged with all those great little tools like TensorBoard.
Absolutely. And that really is it. When you go and talk to almost any data scientist in the world today, they often have very dispersed environments that they'll need to run in. They want to be moved to wherever the data is. They may have petabytes of data that they want to process, and that may not be in this cloud or that cloud. And what they're really looking to do is get to an environment where they can think purely about the model and let the separation and IT ops take care of it for them.
Awesome.
What you didn't see there were some really important points. First, you didn't see any bespoke solutions. These weren't custom new ML frameworks. They weren't brand new open source solutions. We're using existing, very popular open source technologies today that you can use or swap out for your own. Things aren't like insanely tightly wired together. Second, you didn't see any cloud-specific technology. Even when we were deploying to Google Kubernetes Engine, we were using this exact same software that we had running locally. All we did was swap out our parameters. And then finally, you didn't see any forking of the Kubernetes APIs, meaning anywhere you have a Kubernetes compliant cluster, it's going to run great. And really, this is going to empower a brand new set of data scientists and other people in the world. There's a great story out of Sweden where a group of scientists were able to look at a number of data and identify that what they were doing wrong was they were plowing the wrong streets at the wrong time. And stay-at-home parents and women who happened to not be at work that day ended up being injured far more frequently because in light snow situations, they would be tripping and falling on sidewalks when cars could actually handle it. So by looking at the data scientists and using frameworks just like KubeFlow, they were able to see that they could make a huge impact in people's lives without any change or any other budget, just by changing the order. And that's really what we need to do as far as using KubeFlow, is really empowering everyone at the various levels to make smart decisions and help them, make the world a better place. And by doing that, by focusing on giving people clean layers, by giving the data scientists the ability to make these decisions, they're able to hand off to the next layer above them to make even better decisions and really change the world. We are just getting started with KubeFlow. It is 0.1. It's a little early for running in production, even though all the components of KubeFlow are battle tested. Things like TensorFlow, as I mentioned, TensorBoard, Jupyter, and things like that have been out for many, many months. KubeFlow is still brand new, but we do have a lot of people helping. You can see a small subset of people who are contributing to the platform today. And then what's next in KubeFlow 0.2, which we hope to have out by this summer, we're going to make it even easier to set it up, integrate with more and deeper Kubernetes features, and a lot better packages. But really, the feature we'd like to have is the one we haven't heard yet. There are many, many data scientists out there that are trying to solve the problem, and KubeFlow is entirely an open source project. Though Google contributed to it significantly, we have over 70 contributors from 17 different companies working on it today, and we want to make sure it truly does run everywhere. And so if you find that there is a machine learning problem that you're running into today, we would love to hear about it.
We're on GitHub, so.
Exactly. And so with that, that's a wrap. Like I said, we have all the various places for us to reach out, and I think we're going to take just a moment to collect the questions.
All right, we're back, so let's go into some questions here. What does the adoption of KubeFlow look like in the wild?
So the reality is, I wasn't joking. KubeFlow is a 0.1 release right now. We would actually not recommend using it in too many production workloads right now. That said, we have heard many, many stories, and you can go and check out the KubeFlow.org website coming soon, not quite available yet, or our GitHub repo to see a number of places that people are using it today. In the examples directory, you will already see a great number of examples there, a solution around GitHub summarization, GitHub issue summarization, Tensor to Tensor is obviously built in, and a number of other ones where you can download and start experimenting with KubeFlow today.
Awesome. So does KubeFlow run on GKE?
Absolutely. So the demo that you saw there was KubeFlow running on Google Kubernetes engine, and it obviously runs great, and it takes advantage of all the elements that are available in Google Cloud, node pools, preemptible VMs, GPUs, TPUs, so on and so forth. But like I said, it really does run anywhere Kubernetes runs, and so that might be another cloud or on-prem. But obviously, we think that we can do a pretty good job serving KubeFlow on GKE.
Of course. Oh, here's a very interesting one. When would I use KubeFlow over Cloud ML engine?
Absolutely. So this is a question we get a lot, and the reality is Cloud Machine Learning Engine is fantastic. We strongly recommend it. What we have found, though, is that oftentimes data scientists might want to swap out or need something in a hybrid or on-prem solution. And in those cases, that's when you would want to swap out. So basically, the summary is, if you'd like a hosted solution where you really don't have to think about anything under the hood, you just want to hand a model to something and get back an answer, or use it for inference, Cloud Machine Learning is fantastic, and we would strongly recommend it. If you have customization, or you want to do on-premises, or you want to do a hybrid scenario, KubeFlow would be your best bet. And they really do layer over each other very nicely.
Right, so right tool for the right job kind of thing.
Absolutely.
If I am a ML data scientist, how will KubeFlow simplify my daily life rather than complicate it by adding the Kubernetes layer?
Absolutely. I think one of the biggest things here is that a lot of data scientists really want to operate at that next level up. I mean, I can't tell you how many data scientists. I was just talking with a fantastic researcher last week who literally couldn't reproduce their experiment from a year ago because the versions of Python had changed and they weren't sure what happened and their library dependencies had failed. KubeFlow allows you to describe your entire framework in a containerized, hermetically sealed, dropped in amber kind of scenario, and really detail it forever. And so that's something that you can share with your colleagues, you can put in a research paper, all those various things. And it means you also don't have to solve all the problems under the hood. You don't have to deal with service discovery. You don't have to deal with provisioning persistent disk. You don't have to deal with attaching drivers and GPUs and things like that. Kubernetes takes care of all that stuff for you. Now, that said, if you are just experimenting and you want to use a single, we call it kitchen sink container, that could be perfectly fine. What we found, though, is more often than not, what happens is that immediately following that experiment, a data scientist has to completely rewrite their entire model, completely rewrite all their dependencies and setup, and have a lot of trouble even reproducing the experiments they were doing in the first place because that experiment that they were running initially is no longer production ready. And that's where we hope to make a lot of distance with KubeFlow. Kubernetes is very, very easy to set up. It comes in Docker. It has MiniCube as setup. And then you can deploy, you can describe and deploy your entire framework of KubeFlow onto that local cluster. And that is a production-ready solution. That's something you can take elsewhere.
Very good. Yes, Kubernetes, there's a little bit of a learning curve with it, but it's pretty easy to set up. And again, it's much easier, as you mentioned, to control versus learning how to manage a Yum or apt repository and get all the right dependencies and everything. So
yeah, I mean, the demo you saw today was totally, live, real demo. And you saw no Kubernetes commands, literally none, other than just to show off, that something was actually running. All the systems for running and trying your model were built in and at that data science layer that you're all familiar with.
All right, looks like we got one more question here. What about data and model versioning?
Absolutely, that's something that's very actively being discussed in the KubeFlow community right now. We have heard this request a lot. This is something where we really do want to empower the community to make these decisions and help think about what should come in the box and what isn't. KubeFlow isn't trying to solve a lot of these problems. We're really packaging the best of breed that's out there today. And so in many of those discussions that are happening right now in the cloud, or excuse me, in the community, you are seeing folks begin to come up with some norms about what data and model versioning should look like. And when those norms land, we will ask people who want to participate in those discussions to snap to those norms, which basically say, hey, if you're going to run a machine learning, or excuse me, a model version or a data versioning pipeline, you should do 1, 2, 3, 4. And as long as any solution comes along and does 1, 2, 3, 4, it should run fine.
Well, that's great. Well, thank you, David, so much for joining us and telling everybody about the wonders of KubeFlow. Hopefully we can get some people to start using it and start contributing, and we want to see all those pull requests coming into GitHub, and also hear your success stories. So it's definitely been great to have you.
Absolutely, thank you so much.
Well, thank you very much for watching, and please tune in to Tuesday's Cloud on Air next week and every following week.